Hi, today we're looking at a very interesting little logic puzzle called Trilogy. This is what the board looks like, and as you can see, this puzzle has no numbers. Instead, the puzzle is based around symbols like the square, triangle, and circle. 3 symbols, hence the name. Now, this is a very simple 1-star level 1 puzzle. This has come from Puzzle Weekly presents Trilogy. It's a very nice, easy starter puzzle, which is ideal to learn the rules. So what are the rules and what is the objective? Well, the objective, as you can probably guess just by looking at the grid, is to complete the grid, fill in the missing cells, or these empty cells like this, with the missing symbols, which must be squares, triangles, or circles. And to do so, there are only 2 rules to remember. It's very easy to learn. The first rule, rule 1, is that you cannot have the same symbol 3 times in a row. So if we look up here, for example, we've got 2 squares and an empty cell here. The empty cell cannot also be a square because that would be 3 squares in a row, and that's not allowed. So that's rule 1. Can't have the same symbol 3 times in a row. Rule number 2 is kind of the opposite of rule number 1, and that is that you cannot have 3 different symbols in a row. So if we look at this row here, these 3 cells, we've got a circle, a triangle, and an empty square here. We cannot put a square in this cell because that would be 3 different symbols in a row, which is also not allowed. Where we're talking rows, just to be clear, we're talking about looking horizontally, and we're also talking about vertically, and we're talking diagonally as well, in both directions. So for example, here we have 3 cells diagonally, a couple of squares, so this cell cannot be a square because that would be a violation of rule 1. So those are the only 2 rules. I need to hurry them out. Contrary to lots of logic puzzles, where it's often easier to start on the edges or corners of a grid because you have more constraints, Trilogy is usually easier to start towards the middle of the puzzle because the constraints are the symbols that are already on the board. So it's easier usually to start in crowded areas of the board. Let's begin with a look for some easy wins, as we always do. There are certain patterns that come up time and again in Trilogy. And one of the most common is this pattern up here, where we have a circle, an empty cell, and then the 2 squares. So we're looking to fill in this square here, and it's very easy to work out. We said it can't be a square because then we'd have 3 squares. And also, it can't be a triangle because then we'd have on this side 3 different symbols. So the only symbol it can be is a circle. In here, we'll move all that in now. Now, I call this pattern an ABB pattern, or an AXBB pattern, and that's because if we take the circle and call that symbol A, and then we call the square a B, and the empty cell we call X, then as we've determined, the X cell must solve to the same as A. So we could write that as an equation. Don't worry if you hated equations. In math class at school I did too. But bear with me, this is worth it, honestly. If we write AXBB equals A, that reminds us that anytime we see this ABB pattern, then X must always equal A. There are lots of patterns like this that you will come across in Trilogy. This is probably one of the most common and definitely the easiest to spot because you could just look for the 2 B's, the double symbol together, and then see if you can find a space with another symbol next to it, and then you found an ABB, and you know that the empty square must be the same as the A symbol. So that is what I call an ABB pattern, and on this board there are quite a few of those already, and as we go through and fill in more cells using other patterns, the ABB pattern will come up time and again. So look, we've got a vertical ABB pattern here. This time the A symbol is a triangle. Same pattern though, we go triangle, and then a repeat of 2 squares down here. So we know that this empty cell must be whatever the A symbol was, which in this case is the triangle. So we have to put a triangle down there. So we've got another one here with a circle and 2 squares. So we know that that's a circle. And having just filled in this circle here, that has created a new AB pattern here with the circle and the 2 triangles. So we know that this empty cell here must be a circle as well. Here's one, that's a circle, here's one, looking the other way, we're looking that way, we've got the square and the 2 triangles, so we know that we need a square. But actually, it was also an ABB pattern looking down this way, wasn't it? I'll do a few more of these and then we'll look at a different kind of pattern. Here's one down here, which has just created a new one here. So square, that has created a new ABB here. Got one up here, square and two circles. So that's a square, which has created another one here. Obviously, this is an overall one puzzle. This is why we get so many of these ABBs. They're very easy to see. And we've already got a lot of symbols on the board, which is why we're getting so many of these patterns. Okay, let's look at a different pattern. And this time we're going to look at what I call an intersection pattern. And this is where we have two patterns with an intersecting empty cell. What do I mean by that? Let's take these two cells here, the two circles in a diagonal row with this empty cell. And we also take these two triangles that are in a row, which have the same intersecting cell. So just to be clear, this cell is the one that we're trying to solve. And it's in a row with these two triangles, and it's in a row with these two circles. This is an easy pattern to spot again because we're looking at doubles, two circles, two triangles with an intersection. So if we call these circles with the A symbol and we call the triangles the B symbol and we're trying to solve for X in the middle, then again, we can write that out as an equation AAX BBX equals, so the X then again is that one. And again, this is easy to work out because we know we cannot put a circle here. We'd have three circles in a row. And we know we cannot put a triangle here because there are three triangles in a row. So it must be a square. A square isn't A or B, so it must be C. So we can write our equation as AX PPX equals C. So anytime we see an intersection of two doubles like this, then the intersecting cell must be the third symbol. So we'll put our square in here and look at that. It's given us another AABB pattern here. We've got the two triangles and the two squares, so we know that the intersecting cell here must be the third symbol, which in this case is a circle. Now in a very simple puzzle like this one, these two equations or these two patterns can get you a long way, possibly even to the end of the puzzle. There are lots and lots of others that you can pick up. We've got some of them are listed on a tutorial on our website. There's a link to that in the description and a table with some of those patterns, or you can just work them out as you go along. So where are we up to? We've solved almost all of this half of the puzzle. Let's come and have a look down and see if we can just solve these last few squares down here. Let's see if we can solve this one first. We can use logic to work that out. If we draw the window around these three cells, we know that we cannot put a square here because we will be creating three different shapes in this set of three. So it can't be a square. And it also cannot be a triangle because if we had a triangle here, then on this set of three, it also had three separate shapes. So the only possible symbol left is the circle. So we know we must put a circle here. What about this cell down here? Well, this is a bit more difficult. This is on an edge. And as I said, we don't necessarily have constraints on the edges, or we have fewer constraints. We're not constrained by three cells in this direction because we're too close to the edge. We're certainly not constrained in this direction. We have a constraint here that says we can't make this a circle because that would be three circles in a row. Then we also have a constraint on the diagonal, but the constraint on the diagonal and the constraint here both allow a square or a diamond here. Either one would be fine. So we can't solve this cell until we have further constraint. The only way you can do that is to look over here. So we have to solve this cell first. So is it possible to solve this cell? Yes, I think it is. If we look along these three here, we've got a triangle and a square, so we can't have a circle there. If we call these three, we've got a circle and a square, so we can't have a triangle here because we'd have three row there. So if we can't have a circle and we can't have a triangle, that just leaves a square, so we know that this cell must solve to a square, and that now enables us to solve along here because we can't have three squares in a row, so we know that this has to be a triangle. Now I think we've got a few more patterns that we can use up here because solve this cell because we've got two squares that way and we've got two circles that way, so we know it has to be a triangle. It's our old AABB pattern again, and down here we've got 2 circles there, and we've got the 2 squares there, so that has to be the triangle. Another one up here, look, we've got the 2 triangles there and the 2 squares there, meaning this has to be a circle. And for completeness, let's come back and look at this one, so we can, for this is bottom part of the puzzle, or if we look along here, we can't have a square in there, because that would be 3 different symbols. We can't have a circle in there, because that would be 3 different symbols this way, so this has to be a triangle. Same thing going on here. Circle, square means we can't have a triangle in there, and triangle, circle means we can't have a square in there, so we have to put a circle in here. And that diagonal there should now allow us to sell this corner, because we have a circle and a square, so we can't have a triangle, or we have a triangle or a square, so we can't have a circle. So this has to be a square. I just spotted become a nice easy ABB padlock here. That's a triangle. So again, we'll carry on working around the inner part, working out towards the outside like this, simply because we have more constraints. Let's have a look at this one. Well, we've got a circle and a square, so we can't have a triangle here, because that would be 3 different symbols in a row. And we've got a triangle and a square here, so it can't be a circle, because that would be 3 in a row. So it has to be a square. That gives us an ABB here. So that's a circle. That gives us some ABB here. So that's a triangle. ABB up here. So that's a square. And we've got AABB intersection here, making this square here the triangle. So this is easy to solve. Can't be a triangle, because that would be 3 in the row. Can't be a square, because that would be 3 different. So it has to be a circle. This one here can't be a triangle because of these 3. And it can't be a circle because of these 3, so that must also be a square. And your couple left, can't have a circle here, obviously, because that would be 3 circles in a row. And we can't have a square, because that would be 3 different symbols in a row. Truly not. So 1 symbol left here, can't be a square because of these 2, and it can't be a circle because of these 2, so that's another triangle, and that's it. We've solved the grid. Quite an interesting result of this puzzle, because actually we've ended up with, by the look of it, pairs everywhere, which is very unusual, but that's just the way that this one has fallen. So there we go. We solved that using mainly the AXBV and the AAXBVX formulas, the patterns. The puzzles get considerably harder, the grids get bigger, and we have far fewer starting symbols on the grid. Here's an example of a level 7 puzzles. This is number 111 from the same book. There's a link to the book in the description if you want to have a look. And as you can see, no immediate patterns on a grid like that. If you'll have a go at these yourself, there's a taster pack you can download for free. There's a link in the description. It's got a few puzzles of this level and a couple of harder ones as well to have a go at.
Hi, I'm Dora. Don't forget, you can get our Puzzle Weekly magazine delivered to you every Monday, completely free. Visit the link to get your copy.